Okay, this is the Wisconsin Lighting Lab WiLLcast. My name is Adam Rupp, and today my guest is Mark Hubbard. He's a field applications engineer with a company called Littelfuse. Mark, welcome to the WiLLcast.
Thank you. Thanks for having me.
Yeah, absolutely. Let's start out by give me a few background details on Littelfuse, where you guys kind of position yourself in the market, and then your background in the industry.
Sure. Littelfuse is over a 90-year-old company, and we kind of grew out of circuit protection, and we currently have the broadest and deepest portfolio of circuit protection products in the industry. We're also accelerating our growth in other synergistic areas, including power semi-control products, as well as sensing devices in that area. From a circuit protection standpoint, because of the breadth of our product line, we offer anything to protect anything that uses electrical energy. So this can be applications that are connected to the AC mains, DC power ports, as well as telecommunication and datacom interfaces. And we also cover several different markets because of our breadth of product, anywhere from consumer to industrial to automotive, medical, mil-aero, and of course lighting.
And when I think about the electrical grid and why a company like Littelfuse exists, I think oftentimes it's kind of misunderstood. We all use electronics products, whether it's at our homes and our businesses, pretty much anywhere. And when you look at power generation, power distribution, and then local power distribution panels, what is the need for protecting circuits, for protecting products in your mind?
Yeah, there's several different kinds of faults, and really we're trying to protect against certain abnormalities that can occur on the grid or on the line. And we offer products that protect for overcurrent type of situations. It's really more like a short circuit fault or a ground fault type of issue. But also on the grid, there are surge events that can occur. And a surge event is essentially a short duration release of electrical energy. And this can cause large spikes on the line that can cause high voltages. They typically will last within a few microseconds to maybe several milliseconds, but they can cause all kinds of issues or damage, anywhere from a soft failure such as latch up or malfunction of the equipment, all the way to hard component failure, or even potential a safety issue for the user. So it's important to ensure that you have the proper protection on the lines, one, to keep your equipment operating, because anytime you have down equipment, that becomes costly, as well as the cost of having to actually do the repairs.
All electronic products are built to a certain electrical spec. They're designed to work with a certain voltage, a certain amperage within a certain tolerance. And in many cases, by the time the power gets to the product itself, it's out of tolerance. It might be out of tolerance for a brief second, or you might have certain instances where utility transformers are out of their operating tolerance. And when you guys are protecting circuits, protecting products, where do you start? Do you start, at the distribution panel within a building? And then I know you also, we use some of your products on board with our fixtures, but your breadth of products, where do they start in the circuit itself?
Yeah, it's a good question, and really it does. It starts at the service entrance, from the service drop from the utility down directly into the building itself, and as well as in the distribution panel for both over voltage and over current. So at the distribution panel, you have branch protection or over current protection to protect against any type of a ground fault, which really is there to prevent fires or potential shock hazards, but as well as transient events that can occur. And having something at that service panel or distribution panel is kind of the first line of defense into the facility. Now, typically, though, that's only going to protect you to a certain level. It's designed to handle a large amount of energy, but even at that point, there's still going to be some let-through energy because it's only going to protect down to a particular level. So it's also important then throughout the system itself that you have at different points you have protection, whether it's at the distribution panel or even at the end equipment. Because by the time you get to the end equipment, hopefully that energy has been knocked down to a good level, but you still want to ensure that your equipment is well protected to protect any let-through energy that might occur.
Yeah, and over the last year, our engineering team, we've been doing a deep dive into surge protection and really power management in general. As lighting has transitioned from the legacy technologies, HID fluorescent to solid state technology, I think people are starting to realize how much more susceptible those products are to transient voltage events. And what we've done is we're trying to take a holistic approach to it rather than just focus on on our lane, which is design and manufacturing product. If our products are being plugged into complicated electrical systems, we really need to understand everything from the panel all the way to the product that could be 80 feet up in the air. So, when you talk about kind of that cascading, protection, it's panel, and then like for a sports application, it would be the base of the pole, and then on the fixture itself.
Right. Yeah, and you bring up a good point too, especially considering legacy lighting when it's high pressure sodium and those types of technologies. Those are very robust. So
why is that the case? Is it because the ballast was transforming the voltage and it was able to handle more of those transients? But why is that technology more robust?
Yeah, it was just the way it was set up because of the ratings or the levels of energy that those types of technologies could handle.
I see.
Either short duration or even handle certain low voltage situations or things like that. But when we start to move to solid state by nature is more sensitive. And that's where the LED lighting comes in. And that's what I think a lot of people started to realize as they started to transition into LED lighting. The benefits are great. You get lower power usage, you've got long-term reliability, but especially in an outdoor application, to realize that long-term reliability that you can get out of that fixture, you have to make sure that it's protected and can hold up under transient events. Mm-hmm. And because of the greater sensitivity due to the solid state nature of it, you are going to need to start adding in some extra protection to make sure that you're going to achieve that longevity that you're trying to get out of this new technology.
And it's funny too, historically, I think when LED light fixtures have issues, a lot of people, their knee-jerk reaction is to blame the driver. The driver is failing. It must be a bad driver. It must be overheating. There's a whole host of reasons that people thought it was failing, and I never liked that explanation because in my mind, it's a symptom, not the cause. And you really have to go further upstream to understand why the driver is failing. And as we started to dive into it, it didn't. Our investigation, it didn't even stop at the pole level. It's then you went back to the distribution panel. Then you realize that in some cases people aren't measuring the output of the transformer. And again, especially for mission critical applications, sports lighting, high mass lighting, applications where the products are tough to service, having that holistic approach is important.
Yeah, it really is important because that's a lot of times that's where these issues are coming from. They're coming from the grid. They're coming from the system, from the electrical system. And if you don't have a well-regulated or reliable system, that's going to start to wreak havoc on the equipment that you're attaching to it.
And you talked about outdoor applications being more susceptible. I think that I look at indoor applications too, and when I walk through industrial plants, even hospitals, other types of facilities that have had solid state electronics for decades. You look at CNC equipment, you look at robotics, automation equipment. People in that business have known for a long time that for this piece of $10 million machinery to operate properly, it has to get good power. So did you guys, a lot of your expertise, was it learned in those types of applications and now it's getting applied to lighting? Or what other types of jobs, indoor and outdoor, do you see where the same type of tender loving care needs to be given to them, just like lighting products as well?
Yeah, it really did kind of grow out of what we have experienced in the industry. And when we start, it's funny when you talk about indoor applications, like you said, those have been around for a long time. We've been protecting those types of devices for a long time, but the exposure level that you generally have in an indoor environment is a lot different than you're going to have in an outdoor environment.
Sure.
One, it's in a building, it's an enclosure, which is going to help limit some of the transient events that can be ingressed into the facility. Not to mention you have the upstream protection at the service entrance, and then that propagates down into the protection at the equipment level. So generally, you don't need something as robust as you might need in an outdoor application. So when we start talking about outdoor applications, now you're out in the environment and you have a much higher exposure level. The other issue too is generally you're going to have long runs of cables. Maybe in a facility you only have a short run, maybe it's 30 meters or something like that, or 30 feet. But when you get outdoor, now you're talking hundreds of feet of cabling that's being run from the distribution panel to the pole and then even up the mast to the light fixture itself. And that in and of itself becomes an exposure point. So when for instance, a lightning event occurs, the amount of large current flow that goes through the lightning event creates a large electromagnetic field, and that gets coupled onto the cabling that's either above ground or below ground. So if you're on a transmission line, that gets propagated into the facility where it meets the primary protection, and then gets propagated down the line. Whereas an outdoor, it can even be propagated past the distribution panel into the cabling that's running from the distribution panel to the light and even up the pole. So it's even more important to have a level of protection at those different locations.
Excuse me. So at the panel itself, the distribution panel, you're making sure the incoming power is regulated between the transformer and the panel itself. From there, let's say a sports application, between the distribution panel and the light pole itself, you'd want another combination of surge protection fusing at the base of the pole to more or less protect that circuit underground between the panel and the pole. And then the onboard at the fixture, you'd want a third layer to protect anything that happens between the base of the pole and the top. Would that be a general architecture?
That's general architecture. Okay. Plus, it's also the stuff that can occur between those locations, but also if it occurs on the mains through the distribution panel, there's still some let-through energy that gets through. So it's also there to try to protect even from a mains type of an event that gets propagated through the line. So it's really twofold in a way that you're trying to protect both.
Got it. Do you guys do anything with voltage sag, or is it pretty much on the surge part of the problem?
We really don't. Yeah, that's an area we don't really deal with regulation or noise or voltage sag. There's some impedance devices that can be used, or filters that are typically used to deal with those types of events. We're really more focused on the transient or surge event protection level.
Okay. And when it comes to electrical impedance, I know we've had some of our systems tested just to ensure that say there's a parallel wired surge protector on board in the fixture. We know there's been some cases where if there is a transient event, it still will affect the driver before it affects the surge protection device. What type of testing do you do to make sure that those impedance values are matched?
Yeah, that's something we found too as we were growing in this industry as well. We discovered that there's a coordination issue that can occur between the external module protection used in the fixture as well as the protection that's used internal to the driver. So the drivers themselves have a certain level of protection, and this can be anywhere from 4 kV to 6 kV typically. There are some that are looking at 10 kV, but usually 6 kV is about as high as they will go, which is fine for an indoor lighting type of application. But as you move that outdoors, and that becomes insufficient to protect against the type of events that you might experience. So that's why you use a module on the outside. The problem is, depending upon how those match up, whether it's their voltage rating or the amount of impedance that's in between, it could still end up that or too much energy, not all of the energy, but too much energy still gets pushed through the driver itself. For instance, if the voltage rating is slightly lower on the surge protection that's in the driver as compared to what's used as the module, it will turn on first and it will start to take more of the energy. And therefore, you're still dissipating some energy in the module, but it's not limiting it enough to protect the driver. So there's things you can do to try to help with that. And the main thing is try to make sure there's enough impedance in between the two devices, or coordinating impedance or inductance. And it's not really practical to add an inductor into the line, but sometimes the cabling itself will offer that level of protection. The other option is really just test it with the driver, just to ensure that there is that coordination between the module that you're planning to use as well as the driver that you're planning to use. Or we've also done some development where we've added in some extra electronics into the module to reduce the amount of let-through voltage to help with that coordination issue.
So what type of testing equipment would you recommend for either contractors who might test the panel surge protection versus some of the other electronic components, then more like for factories that are manufacturing product, once they have their system architecture in place, if they wanted to test and match the impedance values between the surge protection devices and the drivers, what's available for factories to test those systems? I know we do a high pot test, I believe, but that doesn't necessarily test the surge protector versus the driver. I believe that's testing just the ground continuity in the system. But what other equipment might be available?
Yeah, ground continuity is important, and it helps, but high pot is really more of a test of the insulation resistance of a system. It doesn't really help test against transient events like lightning or EFT or inductive switching type of events. To do those, really need to test those in a lab. and using things like a combination wave generator, which is really designed to simulate a lightning strike at different voltage levels, as well as an EFT tester, which is designed to test switching of inductive loads on a system or on a line, as well as some ring wave testers as well. And if you're going to do that in a lab too, typically you want to do it as it's connected to the AC mains, because where it happens on the phase of the AC cycle can have an effect as well. So typically you'll need a coupler-decoupler network to allow to attach the power to the fixture itself, but isolate the transient from the rest of the electrical system so you don't cause any additional damage.
So for us, it sounds like you have a relationship with a good lab.
Yeah,
and might get a little complicated if we try to do all that on our own.
And that's obviously something we can help with. We actually have a lab in Chicago. We have a couple more globally where we can do this type of testing. If you can provide us with the fixtures, or just the drivers and things like that, we can help identify if there's going to be a coordination issue with the particular topology or setup that you're using.
Okay, well, very cool. So rules of thumb for let's focus on outdoor sports applications. We work on a lot of jobs. It could be a recreational ball field. The electrical infrastructure has been there for 40 years. The transformer might be several decades old.
Okay.
If you were in charge of specifying electrical protection equipment for that type of application, and it's a customer that might be on a budget. It's a contractor that's in charge of sourcing all of the electrical hardware. What are the rules of thumb you would use starting at the panel itself?
I think it's probably best to refer back to some of the standards that have been developed that provide guidance.
Is that an NEC code standards or going above and beyond NEC?
Kind of above and beyond. So
Okay.
NEC is sort of the base level standard, but it a lot of times will reference different standards when it comes to certain aspects of the electrical grid and how to test for it. For instance, like IEEE C62 is one of the primary standards that's used for developing a simulation type of waveform or test for lightning or other types of transients. And usually they'll pull from that to say, okay, here's the test levels, here's the waveform, and these are the types of things that you could experience, or if you meet these, you're in a much better position to be able to survive these types of events once you hook them up to the field or once you're in the field. Granted, it's in the field, it's all over the place, right? Yep. But they've done a lot of studies of systems and grids and whether it's lightning activity or switching, and that's how they've developed these simulation standards or guidelines on how to test to ensure that your equipment will hold up.
And in terms of the product itself, say it's an off the shelf surge protection device, what should a contractor look to source if they kind of wanted to take care of all of those potential issues? Would it end up being I don't know if it's a type 2 or a type 1 surge protection device that gets hooked in parallel at the panel? But if you had to kind of cut through all the noise and just say this is the part that you would need, assume it's installed properly, it should take care of 80% of the issues. What type of device would that be at the panel?
So at the panel itself, I think primarily you're going to be looking at a type 2 type of SPD, because that's really anything that is going to be connected on the output or the load side of the distribution panel would be a type 2, and this is per the UL 1449 standard.
Okay, perfect.
And the type 2 device, though, can have different levels of capability. So for instance, if you look at the standard from a surge aspect, it can range anywhere from 5,000 volt capability all the way up to 20,000 volt capability. 5,000 amp to 20,000 amp capability. So if you're unsure of your system and how well regulated or how well protected it is, then you may want to go to the higher end of that level to ensure you have the best level of protection. If you know that it's a pretty well controlled line, then maybe you can go down to the lower rated type of SPD. Type 1 is actually at the service entrance, so that's really kind of in front of the distribution panel or the meter. So that's kind of a different sort of aspect, and those are typically going to be either 10 Ka or 20 Ka rated type of devices.
Okay, and then at the base of the pole, what type of device would that be?
At base of pole, you can also look at a type 2 type of protection, or you could even potentially look at something that's more of a type these are considered type 4, so these are modules. Generally, these are used in the fixture. You could also consider using them at the base of the pole for some added protection. But at that point, it doesn't necessarily have to be a type 2, type 1 rated type of device, because that's really more what's required at the distribution panel. The standard calls out that once you go beyond 10 meters or 30 feet, then it starts to become a type 3 type of protection device. So there are some of those available too that you might be able to consider using at the base of the pole, which is more of a type 3 level, which is a lower rating. But given that this is an outdoor application, you still might want to consider a higher surge level in the, probably in the 5 to 10 kA minimum type of rating.
Bigger is better, right?
Yeah, bigger is better, right.
And do you have a suite of products, bolt-on products, or are your components going into other products?
A little bit of both.
Okay.
So as I think we talked before about type 1 SPDs,
Yep.
and that's really a piece of equipment. And an SPD has different aspects to it. One is its ability to protect against surge. Another, it has overcurrent type of capabilities, whether it's an intermediate current or short circuit current level. And we provide the components that go into those devices. So primarily, you're going to find something like a metal oxide varistor product, and this is going to be the primary surge protection device that's used in an SPD or surge protection device.
That's inside that mold.
Correct, and that's also what's used inside these molds as well, and
I see.
they're also the type of devices that are used inside type 1, type 2 surge protection devices. And then we also offer sort of assembled devices, which are more what you see here, which were designed specifically for the lighting industry for outdoor fixtures. And these also include these suppression components, as well as some other mechanisms there's a mechanism for thermal protection, and in some cases, like with the coordination issues, we'll add in some TVS diodes or GDTs for isolation. So it really just kind of depends on what the requirement is of the system that is needed for. So,
do you do anything with power monitoring or surge spike counters or other types of voltage and power monitoring?
We really don't.
Okay.
There are power system analyzers that can be used to measure not just spikes, but they can also be used to measure power quality, whether there's variations in frequency or voltage or sags or swells, those types of things. You can collect that data in real time. Surge events are a little more tricky because they're more infrequent, so they don't happen quite as often. So usually something like a data logger can be used that will take measurements over a long period of time, and then you can analyze that data and kind of see what your transient activity looks like, which could give you a much better idea of what level of protection you might need for that system.
Okay. So where do you see things going in the lighting industry with your product suite? Are you guys developing more products to solve these issues, or are you guys comfortable where things are at right now, or what does the next few years look like from a product standpoint?
Yeah, it's been kind of a growing process for us through this. This was kind of our first entry into the lighting protection system, where we integrated into a module like this. And as we've grown with the industry, we've come across different needs. For instance, though that was primarily just an MOV type of protection, but as we started to look into the European territory, you can't connect MOVs to ground in certain systems, so we were adding in GDTs to provide that isolation, as well as then with the coordination issue, we were adding in TVSs and some inductors to try to cut down that voltage level, so we're limiting the amount of energy that goes into the system. And the industry is also very price sensitive too. So, we're doing other things for customers depending on the need that maybe are a shrink wrap, not as much functionality, but still provides the protection requirements that are needed. We're adding in indications. So, one of the questions we keep getting is, well, how do we know that the module has failed, or how do we know if it's the driver? So we've added in some LED indications that provide an indication that whether the module itself is still functioning or if you've lost surge protection.
So in that case, if the light is out, it would be the module's no longer functioning?
Correct.
Okay.
Typically,
Yeah.
if the light's on, the module's functioning. If the light's
Okay.
off, then the module's bad and needs to be replaced.
Okay. And I know there's a big debate on parallel versus series wired surge protection. And I know, the best system from a protection standpoint, I believe that would be the series wired, where if the surge protection device fails, it protects everything downstream. But if that happens on day one after an install, that might not be a good thing either. So where do you guys see customers headed from that standpoint, or what do you typically advise customers to do?
It depends on the school of thought and what the customer's looking for, because there's advantages and disadvantages to both aspects, right? So in a parallel connection, if for some reason the module goes out and you don't have surge protection, but your light stays on, and for some customers that's important. They want that light to be on as long as possible under any circumstances. You're exposed to the next transient that's going to come down the line, but that transient may not occur for some period of time. So therefore it may not be an issue. Whereas other customers are, okay, if I don't have surge protection, I want to protect the driver and I want to know that it's out so I can service it. And that's where a series module really comes in, because if it goes offline, it takes the entire fixture offline. So therefore it's protected from another transient because it's isolated from the AC mains, and the light goes out. So you have the indication that, okay, there's a problem, we need to have it serviced. So it's really just a matter of what the customer wants.
It's a preference.
It really comes down to preference. And that's what we've seen in the industry too. We kind of get both schools of thought with the customers that we talk to.
So to me, it would make sense if you guys are handling the over voltage events to possibly look into the under voltage events or some of the other sag situations. We had an issue recently with a job where there was a fixtures being mounted to a crane, and every time the crane would move, the voltage would dip and the fixture would go out. Is it? I would imagine those are less common, but did you see getting into the power conditioning side of things, where you're more or less taking care of both of those issues?
Our forte has been in circuit protection for so long. I have not gotten an indication that we're going to look at more power conditioning or power quality type of products. Doesn't mean that we won't. We're doing a little bit of that more on the very low power handheld types of devices, where we're doing we have some filter components and things like that, but nothing yet to the degree that would be needed for a lighting system like this.
Okay. Well, anything else you'd want to touch on? Anything else we want to cover?
No, I think we covered it pretty well. Maybe just a couple more points on Littelfuse. We talked a lot about circuit protection, and we have the broadest portfolio in the industry. And the nice thing about that is we get to really provide the optimal solution for our customers, because we have multiple technologies that we can offer. So we can really provide what's needed for the application. But in addition to circuit protection too, we're really growing in other synergistic areas as well. I mentioned power semi before. We did recently complete an acquisition of IXIS Semiconductor, which provides high power semiconductor power devices from MOSFETs, IGBTs, modules, as well as some gate drivers and things like that. And we also have a line of magnetic as well as temperature sensing devices as well. And we're going to continue to try to expand and grow that product portfolio as we move forward. So I think you're going to see a lot of changes over the next few years, or a lot of increase in product offering that Littelfuse is going to be offered beyond the circuit protection side.
Cool. All good stuff to help the customer protect their investment.
Exactly.
So, all right, man. Well, Mark, thank you very much. I appreciate the chat.
Thank you, Adam. I appreciate it.